So in this video, we will see the implementation of neural network with iris dataset. So first to implement, we require dataset, and as we are using Google Colab, so we need to upload the dataset that is in CSV file to our drive. Once we upload the data into the drive, then we need to mount our drive using this Colab code, and this is easily available from code snippet. Once your drive is mounted, right, it will ask like some authentication code. Once you enter that authentication code, your drive that is mounted. Once your drive is mounted, you can see your drive here, right? So this is my drive, and under that drive there are different folders that are in my drive. Okay, after that, as we have a CSV file, so to read CSV file, I am going to use this pandas data frame. So I am using that pandas data frame, and I am also using numpy later words. So I am right now importing it as well. Okay, and this is the keras utilities to convert into categorical. Now first understand the data set. Now this is your iris species, and in this data set we have basically three species: is versicolor, setosa, and virginica. So based on the features, and which are the features, is sepal length, sepal width, petal length, and petal width in centimeter that is given, and based on that data we want to classify that into specific species, right? Either setosa, virginica, or versicolor. So this is our task. We want to classify in this three class. Now your data set, right? This is a snippet of that data set that has 150 rows and 6 columns. So we have 150 such data with 6 columns. So first is your ID, right? It identifies uniquely each data. Then your sepal length, your sepal width, your petal length, petal width, and spaces. For each category, we have 50 records. Like for Iris setosa, we have 50 records. For Iris virginica, we have 50 records, and for Iris versicolor, we have 50 records. Now, the first task is from CSV file, we will read the data into pandas data frame. So, this is the function read underscore CSV that is used to read the data from CSV file, right? In my drive, the data set that is iris.csv that is placed under this folder. So this will read the my data set, right? So if I print this data set, you can see here, this is the data set that I have read. Okay. Now the next task is based on some features we want to classify, or we want to, yes, we want to classify the data in three class, right? So we need to first differentiate these features and your class. So first we will do that. This four: sepal length, sepal width, petal width, and petal length. These are your features. Based on these features, you will identify the class. So here your X that contains your features and Y that contains your output. So if I consider this first row, Then 5.1, 3.5, 1.4, and zero point 0.2. These are your features, and the category is iris setosa, right? So what I will do in X, I will fetch all this data, sepal length, sepal width, petal length, and petal width for 150 records. Then in Y, I will fetch this column, right? Iris setosa and all. So this is pandas function to fetch the column. So once we have that X and Y, X is these four columns and Y is this thing. Now the next task. So why this Y, we have three categories: iris setosa, iris versicolor, and iris virginica. Now this three category. So when we categorize something, and specifically for neural network, we want this thing in some numeric form. So we have three class. If I consider this as 0, 1, and 2, so iris setosa, that is 0th class, iris versicolor, that is first, and iris virginica, that is second. So 0, 1, and 2. So I will replace that iris setosa with 0, iris virginica with 2, and same way iris versicolor with 1 in Y. Now in neural network, we cannot have like 0, 1, 2 at the output layer, right? And we have three classes, so we must have three neurons at output layer, and each neuron will predict whether that belongs to that class or not, right? So if first neuron is iris setosa, then it will predict that it belongs to that class or not. Second iris versicolor, then it will predict whether it belongs to that or not, and same way iris virginica. So at the end, what we have some combination of 0 and 1, 1. Means if your class is iris setosa, then first neuron will give you 1 and rest will give you 0, 0. So what is this? This is one hot encoding. I require one hot encoding of these classes. So for iris setosa, that is 100, for iris versicolor 010, and for iris virginica it's 001. So this is one hot vector representation of these classes, right? This is required in neural network at the output layer. So this label encoder will perform that task, and it will give you a white in one hot vector representation. Right? Now your Y, that is array of one hot vectors. So if you need to identify the shape of this Y, then shape of Y is 150 cross 3, because one hot vector length is 3 and 150 such records are there. So here we have updated Y for our neural network. And what is X? X is are these features. Okay. Now next. So we have 150 records. We have separated those records from features and outputs X and Y. Now we want to divide, or rather split this data into training set and testing set, right? So then we can test our model on this testing data. So I will use this train test split function from sklearn. So what it will give me? So in train test split, I need to pass x, I need to pass y, your features, your output. This is your test size, means the splitting criteria. So test size is 20%. So out of 150, the 20% data will go in testing and remaining will go in training. And this will be random, not from one, right? This will be a random train test split. So it will take some data from iris vertosa, some from iris versicolor, some from iris virginica, like this. In this random state 0, you can have other values as well. This will keep, whenever you run this, it will start from that value only. So if you don't write this, and if I run this is the first time, then I can have different train and test. If I again run this, I can have different train and test. If I put this random state 0, every time I run this, I will get same train and test data. So as you know, we have split it into train and test data. Now each train and test data will have x and y. So that's why you can see there's the four matrix: x train, x test, y train, and y test. Right? This is the pair for training: x train and y train. This is the pair for testing: x test and y test. So this is the shape of each splitter. So you can see x train. So it's a training example. So 150, 20% of 150 is 30. 150 minus 30, that is 120. So x train, size of x train is 120. And how many features are there? 4. It is 120 cross 4. What is y train? Y train is our class, right? And we have represented as a one hot vector. And one hot vector size is 3, right? So for each features we have class, and that is represented in one hot vector. Same way x test and y test. So remaining 30 will be in x test, that is features, and your labels, that is y test, right? And this is some of the good representation, graphical representation using Seaborn. If you don't know that, you can refer this Seaborn, right? It will give you a very good graphical representation of your data. So you can see these are the features, right? Features versus features. I am plotting it for three classes, right? So you can see, like, based on your petal width and your petal length, you can see your data that is look like this, right? So you can easily see this is your iris setosa. Means in iris setosa, petal length are small and petal width are also small, right? And same way, that is medium for iris versicolor, and that is large for iris virginica. So this is some of the good representation that you will get using Seaborn. Okay. Now for this, we want to build a neural network, right? So we have four features: petal length, petal width, sepal length, and sepal width, right? So your input layer will have four features. Now we want to build a neural network like this. So first hidden layer with 3 neuron, second hidden layer with 5 neuron, and at the output, this is must, means we are classifying in three class. So at the output you will have 3 neuron, right? Each for each class: Setosa, versicolor, and virginica. Okay. So what we'll do? So First, we will build this structure, randomly initialize the weights, and then, based on our train example, we will train this neuron. And after training this neuron, the weights will be updated. So once that is done, all training parts are over. We will check the performance of this neural network on test data. And here the advantage of Keras library, which is abstract level on TensorFlow, is we need not to bother about like some of the things initializing weights and then back propagation, that is taken care by those libraries. This is our model that we want to build. Two hidden layers with three neurons and five neurons. Output you will have three neurons, and this is your input layer. And in input you have four features, right? And you can see this is a sequential model which have one input layer and you have one output layer. So from Keras, we will import that sequential model and dense that will give you a layer, your neurons layer. Now we will initialize this sequential model. You can have different name over here. Then I am adding the first layer. So this dense layer will add first layer, this one, first hidden layer, not the input layer. It will add the first hidden layer with three neurons, and here you need to specify the input feature length or input data length. So you can see here how many features are there, four. So input dimension is 4, so that's why this input underscore dim is 4. And this that you can specify for first hidden layer only, right? Because later on you have this data, so it will automatically calculate that. But for first hidden layer, you don't know how many neurons or not neurons, how many input features are there, that you need to specify, right? And which activation function we want to use for layer 1, that is relu, right? Okay, now second is this second hidden layer. So in that I have added 5 neurons, and again same activation function is relu. The last layer, that is a output layer, right? In that we have 3 neurons, right? And as this is the output layer, so in the output layer we can use sigmoid or softmax activation function. But as we have multiple classes, we will go with the softmax. So if you have binary classification, then you can go with sigmoid or softmax. But here we have three classes, so we will go softmax because it will sum your probability to 1, right? So it will give you a maximum probability out of this 3. Okay, so we have added the layers, right? Once we have added the layers, we need to compile it, right, to get the structure. Now in that compilation, we need to specify the loss, optimizer and matrix that we want to use. So the loss is categorical cross entropy. So multiple class, so that's why we can use categorical cross entropy and optimizer Adam. So if you not much don't know much about optimizer, you can use this Adam optimizer. There are other optimizer as well, but this will give you a good performance if you use this Adam optimizer. Metrics we are using accuracy. You can use other metrics as well. Once you compile this model, Let's see the summary of this model. Okay, so first, so I've compiled this multiple times, so that's why you are getting here 15, 16, and 17. Otherwise, it's the first time, then you will get 1, 2, 3 likewise. So you can see here the shape is 3, 5, 3. That is as per our requirement, and parameters, that is 15, 20, and 18. So how you get this parameter 15, 20, and 18? See this architecture. So here 15, 20, and 18. Those are the trainable parameters. Means a summation of weights and biases. So we need to identify those. How many weights and biases are there? So if we consider this thing, so weight matrix, that will be 3 cross 4 is 12. 3 cross 4, that is 12, plus for each neuron you have a bias, so plus 3. So 12 plus 3, that is 15. So that's why you get 15 over here. Now next is 20. So here it's 20. So how? So 5 multiplied by 3, that is 15. 15 weights plus for each neuron we have bias. So plus 5. So that is 15 plus 5, that is 20. Same way for output. So if you sum this, you will get 53. So total trainable parameters are 53. Okay. And this is used to get your weights, initial weights. So when you have created this, what is weights? If you want to see, you can use this get weights. Now once we have architecture of our network, we need to train this, or we need to, yes, we need to train this model on our training data set, right? So these are the features and this is the output. On that, I will fit my model. I will train my model. And batch size is 8, means after 8 example, I will update the weights. And once all the examples are over, 120 examples are over, again I will run the same thing, that is second epoch. So such 300 epochs I will run, right? Now let's run the model. This is training loss, right? So all epochs are over. Now after this also you can see what weights your model learn, right? So here you will get some different thing. Right now your model is trained, so I think you will get same value here and later on. But you can check this. These weights will be different. This is the learn weights and these are the initialized weights. Okay. Now let's evaluate our model on test data. So we have trained our model. Now we will evaluate our model on, and you can use dot evaluate to evaluate the model. So X test means features in testing, and this is the output of those testing. So now let's run this. So 100% accuracy means we are classifying with 100% accuracy. Means based on the features, each class that we are getting, that is a correct class. Now let's see how your neural network predict particular class. Okay. So basically what neural network does, that it will find out the probability for each class, and from that it will pick up the maximum one, and based on that maximum it will say that your based on your features, it's flower that belongs to this species, right? So X test means your features, 30 features, and based on the 30 features we want to predict, that is your Y predict. So now let's see what is the features and prediction. So features are 6, 2.2, 4 and 1, 4 features. And what is the output? So this is the probability of each class: Setosa, versicolor and virginica. These are the probability for each. Now your network will pick up the maximum one. So as you can see, this is the 0, 1 and 2. So if you use the argmax function in NumPy, then it will give you the argument of maximum probability. And basically that is our class, right? And let's print it, so it will give you us 1, right? So based on this feature 6, 2.24 and 1, what we get? We get 1 here, right? And basically you will get 1 here, further you will get 0, and this thing will be represented in one hot vector. Now if you want to print a confusion matrix and want to find out different parameters like different evaluation measures like precision, recall, f1 measures, then you can use these functions, right? So what I'm doing, I'm predicting for X test, that is my Y prediction that we have already done over here as well. And then for Y test, I'm finding the class. Ultimately, this is one hot vector, so it will give me the index of that column. So here we have Y test class and here we have Y prediction class. And you can see in both this, right? Is this is a test and this is prediction on test only. The size of this both Y test class and Y prediction class will be 30 cross 1. This is not one hot vector. This is your integer value. Now let's print this here. So out of this 30 test example, right? Each and every example, that means 11 that belongs to maybe Iris setosa, then Iris virginica, and Iris versicolor, and Iris virginica. So we can classify exactly the actual work predicted. So 100% accuracy will get, and based on that you can find precision recall and F1 score, right? And this, if you want to match this Y test class and Y prediction class, then you can print this. And these are the reference from where I have taken this code and put it in way so you can easily understand. So in this code I have used this iris dataset. I will give you this file and this iris dataset. First understand this code, run it, and then take some other dataset, right, which have features and class. And you can take any features, but for starting purpose I recommend you to take features which have some numeric values, and then you can predict something, means you can have a binary class, you can have multiple class. For example, if you take this California housing price prediction task, then this is a regression problem. Means we are predicting the values, right? We are not classifying. But what you can do, you can make a category like A category, B category, C category, D category based on the house price that you have. Right? I think it ranges from 5 lakhs to I think 22,000 something. So you can divide those into different categories A, B, C, D. Give those class to each data. Then based on the features that you have in this housing price prediction data, means your attitude, longitude, area, and bedroom and all, you can predict the category of your house. So you can make that thing, right? Or you can take any other data set in which you have some numerical features, right? If you have categorical features, then you need to convert those categorical features into numeric one, because your neural network accept those numerical values, right? And then you need to run this. Now, another intuition I want to give you is, so these are the features that we are using. So sample length and then sample width and all. Now, what if you have a image over here and you want to predict whether it's a cat or not? In that case, this is your image, and image have length and width, and consider it's a grayscale image, so no channels, means no RGB, right? Only two dimensional. So in that case, how you can fit to neural network? So suppose if you're 10 by 10 image size, so you can unroll it and you can flatten that image like 100 features. Means each feature represent your pixel value. So that will be your input, and rest of the things will be taken care by your neural network. In next lab, we will perform that thing like on MNIST dataset, right? That is handwritten digit, and it calculate it classify from 0 to 9, 10 classes. So we will see that in next lecture. So for next lab, so for today's lab, that's it.